And this project was to basically commercialize one aspect of that technology using RF materials to make transparent conductive films. We basically scaled the process and improved the film properties and developed some touch applications for that film. Well, the main results were essentially improving the synthesis process. We improved basically by a factor of 10 our production rates. We also improved our film properties by something like a factor of 3. The key properties would be the transparency and conductivity, and also other properties like stability. And we began making touch sensors. So that's what our target market is. Our first target market is touch sensors for mobile devices and next generation devices. And we began developing those touch sensor applications. This is kind of progressing electronics technology. We live in a world where electronics is basically rigid. The processes to make electronics are expensive. The factories are huge and expensive. And we're basically replacing that technology with carbon-based technology. So we're making carbon-based electronics in a very low-cost manufacturing process akin to printing newspapers. So it's basically changing the paradigm of the electronics industry. And we're also allowing new kinds of products that aren't available today. When you talk about rigid electronics, like is in your phone is rigid. But if you can make everything flexible, you can imagine the possibilities. So what's shown here is a schematic of the direct dry printing process we've developed. And that's what you see behind us in the factory, but here's it in simple cartoon form. And the basic idea is we introduce raw materials here, and those are basic common carbon gases, very environmentally friendly, very common. We introduce those into a nanobud reactor. That's what you see behind me up on the second level.
The nanobuds or nanotubes are created in the reactor, come down in an aerosol phase, go through the deposition chamber, and are get directly put onto the PET. This is the first manifestation of our direct dry printing that we've patented here at Canatu.
And this is what I mean by printing like newspaper, printing electronics like newspaper. First application, what we're going to market first is 3D touch and flexible touch. So basically, like I have here an example of a touch surface. This is with our touch technology and our film. And this shows you a surface where we have a touch screen here and other touch functions, for instance, a slider on the side. And you can do all of this with our films and our production technologies and with our new touch sensing technology that we started developing this project as well. So this is kind of a new electronic device that you could not do today with existing materials. Oh, Tekes has been, of course, instrumental. Of course, the funding is important. And I think one of the critical things about our cooperation with Tekes is they were very flexible in our execution of the project. So we began with a project just to do the scaling and the basic process improvement, but we saw a clear market pull for our new kind of touch sensors, these flexible, formable touch, and Tekes allowed us to kind of shift the project to focus more on developing that. Very critical, and now we're trying to enter the market with that first touch product.